Now the important question based on normal oblique perpendicular form. Now the question is we have to convert, we have to find, not convert, we have to find the equation in the perpendicular form when the given for the values for P and alpha are there. Now number 1. First of all, let us write it. Now, equation of straight line in normal, or you can write perpendicular. Normal oblique perpendicular form is x cos alpha plus y sin alpha is equal to P. Okay. Now let this be number 1. Now part 1, given P is 3 square root of 2 and alpha is equal to 45 degree. Now substituting the values in equation 1. X cos 45 degree plus y sin 45 degree is equal to 3 square root of 2. Okay. Now x with 1 upon square root of 2 plus y times 1 of square root of 2 is equal to 3 square root of 2. Now what we have done, cos 45 degree is equal to sin 45 degree, because both are equal. Okay, both are equal to 1 upon square root of 2. X plus y is equal to 3 square root of 2 times root 2. X plus y is equal to 6. Required equation is x plus y minus 6 is equal to 0. So this is the answer. Okay. Now for part 2, given P is equal to 6 and alpha is 150 degree. Substituting values in equation 1, again same equation, equation 1. Okay. So x cos 150 degree plus y sin 150 degree is equal to 6. X cos 180 degree minus 30 degree plus y sin 180 degree minus 30 degree is equal to 6. Now cos 180 minus 30 falls in the second quadrant. So in the second quadrant cos is negative. So we can write it negative of x cos 30 degree, and sin in the second quadrant is positive. So this will become plus y sin 30 degree is equal to 6. Now sin 30 degree is equal to 1 upon 2 and cos 30 degree is equal to square root of 3 upon 2. So now equation becomes negative of root 3 by 2 x plus 1 by 2 y is equal to 6. negative of root 3x plus y is equal to 12. Required equation, root 3x minus y plus 12 is equal to